Hi, for this video, we will be discussing the sum and difference identities. So for the sum and difference identities, for sine of quantity A plus B is equal to sine A cosine B plus cosine A sine B, whereas if it's sine of A minus B, it's going to be sine of A cosine B minus cosine A sine B. You will be noticing in here that there are two sets of signs. Please take note that the upper signs correspond to the upper signs as well, and the lower signs for the lower signs, meaning cosine of A plus B, it's going to be cosine of A cosine of B minus sine A sine B, whereas if it's cosine of A minus B, it's going to be cos A cos B plus sine A sine B. For tangent, it follows that tangent of A plus B is tangent of A plus tangent B all over 1 minus tan A tan B, whereas if it's tan A minus B, it's going to be tangent of A minus tangent of B all over 1 plus tan A tan B. So let's just try using those identities in verifying the given. Let's go to number 1. So applying the cosine for the left side, we can say that this is cosine of A cosine of B minus sine of A sine of B. And then for cosine of A minus B, it's going to be cosine A cosine B plus sine of A sine of B. The thing is, you'll notice that in this case, you could cancel the sine A sine B. You're left with cos A cos B plus cos A cos B. So that gives us 2 cos A cos B, which is actually equal to what is on the right, 2 cos A cos B. So the identity has been proven. Let's go to the next. So in this case, since we don't know anything that contains tan A, tan B, it's up to you. You might want to use the right side, but let's just try both left and right. If I choose the left side, it's going to be, I can see that this is sine x over cosine x, sine of y over cosine of y. So this one would then be cosine of x, cosine of y, and then on top it's going to be cos x cos y minus sine of x sine of y. And isn't it that here this is one of the sum and difference identities? That one gives us cosine of x plus y all over cos x cos y, which is actually the same as the one on the right. So in here, you can see that the identity has been proven. But what if what I wanted to manipulate is the right side? So what I could do here is cosine x cosine y minus sine x sine y all over cos x cos y. And then you'll notice in here that cos x cos y can cancel out, minus sine and cosine, that's going to be tangent x, and then this is tangent y. But this one on the right is actually the same as the given one, the one on the left. Therefore, the identity has been proven. So it's up to you which one you choose. In this case, we're just asked to verify the identity. So using the sum difference formulas, I can say this is cosine of x, cosine of pi over 2 plus sine of x, sine of pi over 2. And then you can see there's pi over 2 if you want. You can look at the quadrantal angles. This is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. So pi over 2 is the 90 degrees. Take note that for cosine, we look at the x. For sine, you look at the y value. So in this case, this one is actually equal to 0. This one is equal to 1. Therefore, the final answer that you have is actually sine of x, which is what you're trying to verify. However, do take note that what you're trying to verify is that cosine of x minus 90 degrees is the same as saying cosine of negative 90 degrees plus x. So if I were to draw that, negative 90 degrees is the fourth quadrant angle, and then counterclockwise movements are positive, while clockwise movements are negative. So I can say here that negative 90 degrees is this one, or the 270 degrees, plus x, so plus. So that means this one is your angle x. Since it is attached to the y-axis, it becomes a co-function. So I can say here that this one is simply sine of x. And in the fourth quadrant, the symbol for cosine is positive. Therefore, the answer here is simply sine of x. So either you use the sum and difference formulas, or you can use the properties of negative 90 plus theta, or negative 90 plus an angle. If you're asked to find the exact value, just like this one, you'll notice that it's cosine x, cosine y, minus sine x, sine y. I can basically apply cosine of a plus b. So that's simply cosine of pi over 16 plus 3 pi over 16, which is cosine of pi over 4. That is, we can draw a 45, 45, 90 triangle. 1 square root of 2. For cosine, it's adjacent over hypotenuse. If you're dealing with this as your angle, you can say that this is square root of 2 over 2. So that's the exact value. Let's try another one. Evaluate cosine of pi over 12. The thing is, pi over 12, if I don't ask you to convert it to degrees, you can say that pi over 12 factors are the factors that give us 12 as a denominator are 3 and 4. So if I think of numbers that when I add or subtract give me pi over 12, I could say maybe it's pi over 3 minus pi over 4. So let's try. Pi over 3 minus pi over 4, the LCD is 12. 12 divided by 3, 4, that's 4 pi minus 3 pi. That's correct. It gives us a pi over 12. So I can say this one could be rewritten as cosine of pi over 3 minus pi over 4. So it's a difference formula. It gives us cosine pi over 3, cosine pi over 4, plus sine of pi over 3, sine of pi over 4. So now that we have the pi over 3, pi over 4, it might be wise to draw the 30, 60, 90 triangle and the 45, 45, 90 triangle. So let's just say this is the 45, 45, 1 square root of 2. This is 1, 2 square root of 3. So cosine of 60 degrees, 60 is pi over 3, adjacent over hypotenuse gives us 1/2. Pi over 4, so let's select any of the two. It's basically square root of 2 over 2 plus sine of pi over 3, opposite over hypotenuse, that is square root of 3 over 2, and sine of pi over 4, again, is square root of 2 over 2. If you multiply, this gives us square root of 2 over 4 plus square root of 6 over 4. If you want, you can combine them as single fraction. That's going to be square root of 2 plus square root of 6 over 4. So basically, this is the value. What about 165 degrees? So maybe we can think of numbers that we can add or subtract and make it 165. So if I say 180 degrees minus 15, that gives us 165. But then the problem is we don't know the exact values of 15 degrees. So even if this one gives us 165, maybe it's not the best choice. Maybe I can say 120 plus 45 degrees is also 165. Maybe this is a better choice. So let's try. So if this gives us tangent of 120 plus 45, we could say this is tangent 120 plus tangent of 45 all over 1 minus tangent of 120 tangent 45. Now the thing is 120 degrees. We know that 120 degrees is actually 60 degrees in the second quadrant. So this one, let's just draw the 120 degrees. So we know that 120 degrees is actually in the second quadrant. So if, for example, this is your 120 degrees, what's left here is actually 60 degrees. So maybe we can draw a 30, 60, 90 triangle. So sorry, this is not drawn to scale. 60, opposite that is square root of 3. That's negative 1 on this side, and this is 2. And then you have a 45 degrees. So maybe let's draw a 45-degree angle as well. But that's in the first quadrant because it's simply just 45. So this one is your 45-degree angle. That's just 1 square root of 2. So both are positive in the first quadrant. So with those, let's look at the tangent of 120. Tangent is opposite over adjacent, but then that's in the second quadrant, so that's negative square root of 3 over 1. Plus tangent of 45, it's opposite over adjacent, that's 1 over 1, all over 1 minus, again, tangent of 120 is the same as tangent of 60, but in the second quadrant, so negative square root of 3 over 1, and 1 over 1. So simplifying, that gives us negative square root of 3 plus 1 all over 1 plus square root of 3. The thing is, if this is not accepted because it has radical in the denominator, we can multiply this by the conjugate to rationalize the denominator. So that gives us 1 minus 2 square root of 3 plus 3 all over 1 minus 3. So this gives us negative 2 square root of 3 plus 4 over negative 2, or simply square root of 3 minus 2. And it's correct. If you look at this, 165 is in the second quadrant. The value of square root of 3 minus 2 is negative because tangent should be negative in the second quadrant. So let's try another one. In here, the more complicated one is actually the one on the left. So let's just apply the sum and difference formulas. So I can say sine theta cos pi over 4, sin cos cosine, so plus cosine theta sine of pi over 4, and then you're going to add that to sine theta cos pi over 4 minus cos theta sine of pi over 4. So in here, maybe we can already look at what we can cancel. So we can actually cancel the second and the fourth terms. And then now you'll notice that you have a pi over 4. So pi over 4 again is a 45, 45, 90 triangle. So let's just label the sides 1, 1 square root of 2. So I can say that this is sine theta square root of 2 over 2 plus this one is sine theta, and then this is another square root of 2 over 2. So simply that's 2 times of sine theta square root of 2 over 2, or square root of 2 sine of theta, which is the same as what you're trying to prove, that one. Let's try another one. Also, this is being multiplied and then the other one's being, it's a difference of two squares. So let's try the left side. Cosine x, cosine y, minus sine x, sine y, but then you are multiplying this with cosine x, cosine y, plus sine of x, sine of y. So in here, if you multiply the two, it's going to give us cosine squared x, cosine squared y, minus cos x, cos y, sine x, sine y, and then the other one's plus cos x, cos y, sine x, sine y, and then lastly, minus sine squared x, sine squared y. So let's try to cancel what we can cancel. This one cancels out with this. They're basically just the opposites. So you have cosine squared x, cosine squared y, minus sine squared x and sine squared y. Now let's look back at the given. In the given, what you're trying to prove is cosine squared x minus sine squared y. So that means you don't need the cosine squared y. You don't need the sine squared x. All those with x have to be cosine. All those with y have to be sine. So maybe we can keep the cosine squared x, but this one, we can rewrite this as 1 minus sine squared y using the Pythagorean identity. And then this one, we don't need the sine squared x. That has to be cosine. So this one will be 1 minus cosine squared x multiplied to sine squared y. So let's try distributing cosine squared x minus cosine squared x sine squared y minus sine squared y. Minus minus gives us plus cosine squared x sine squared y. You'll notice that this one should cancel. You're only left with cosine squared x minus sine squared y, which is what you want to prove. So now it's verified. It's proven. All right, this is another example. You're given sine alpha, which is 4 over 7, where P, the point, is in the second quadrant. So maybe, so let's draw a second quadrant angle. Let's just say this one is alpha. And then since sine is opposite over hypotenuse, that one would be your P alpha. And then there's a beta, and it says there it's in quadrant number 3. So in here, quadrant number 3, where you'll find beta. If it's cosine, adjacent is 12, hypotenuse is 13. So this is, using Pythagorean theorem in here, it's going to be 5. However, this goes to the left, so that's negative. This is negative. Let's solve for the other side of the triangle with the alpha. So 7 squared is 49 minus 16, that's 33. So that means this one is the square root of 33 using the Pythagorean theorem. However, since this one goes to the left, it is negative. What you're asked to solve for is the exact value of sine of alpha plus beta. So I can say sine of alpha plus beta is actually sine alpha cos beta plus cos alpha sine of beta. So let's look for sine of alpha using the upper triangle. Sine opposite over hypotenuse, that is 4 over 7. Cosine of beta is adjacent over hypotenuse, negative 12 over 13. Plus cosine of alpha is negative square root of 33 over 7. And then sine of beta is opposite over hypotenuse, negative 5 over 13. And then do take note again that the hypotenuse can never be negative. So what is negative is only the x and y if they go to the negative side. So for the x, if it goes to the left, it is negative. For the y, if it goes downwards, it's going to be negative. So let's multiply this. 4 times 12 is negative 48. Over 7 times 13 is 91. Minus minus, that becomes plus. So that's 5 square root of 33 over 91. So if you want to combine this is going to be 91. That's going to be 5 square root of 33 minus 48. So this is the answer. So let's try another one. You're given sine of alpha is negative 3/5, but then alpha is in the fourth quadrant. So let's try drawing a triangle in the fourth quadrant. This is your alpha. Since it is sine, it's opposite over hypotenuse, so that means that would be -3, because again, hypotenuse can never be negative. So this is a 3, 4, 5 triangle. And then sine of beta is 8 over 17. And it says there that beta is in quadrant number 2. So if this is your beta, sine is opposite over hypotenuse. So 8 over 17. So 17 squared minus 8 squared is 225. So 8, this is going to be 15. But then since it goes to the left, it's negative. Let me just check. 8 squared plus 15 squared is 289. Square root of 289 is 17. That's correct. You're asked to find the exact value of tangent of alpha plus beta. So tangent of alpha plus beta is simply tan alpha plus tan beta all over 1 minus tan alpha tan beta. So let's just plug in whatever we have. Tangent of alpha is opposite over adjacent, negative 3/4. Tangent of beta is opposite over adjacent, negative 8 over 15, all over 1 minus negative 3/4, negative 8 over 15. Let's try to simplify. The one on top gives us 77 over 60, then that's negative, all over the one at the bottom, 3. So this is going to be 1 minus 3 times 8 is 24 over 60. So this is negative 77 over 60 all over 1 minus 24 over 60 is going to be 3/5. 77 over 36. So this one would be the final answer. All right. I hope you understand this. Good luck.